This question is from GATE 2017 Mechanical Engineering Paper Set 1, question number 54. A sprue in a sand mold has a top diameter of 20 mm and a height of 200 mm. The velocity of the molten metal at the entry of the sprue is 0.5 meter per second. Assume acceleration due to gravity as 9.8 meter per second square and neglect all losses. If the mold well ventilated, the velocity up to 3 decimal points accuracy of the molten metal at the bottom of the sprue is dash meter per second. Let's find out. In this figure, I have represented the given sprue with the velocity shown at the top of the sprue. Its diameter is 200 mm and the inlet velocity is 0.5 meter per second. Total height of the sprue is also given to be 200 mm and we need to find out the velocity at the bottom. Now looking at this figure, you can guess that you will have to apply Bernoulli's equation because we are being given velocity at one point and we have to find the velocity at another point. And there is an elevation difference between the 2 points. Pressure at both these points can be easily identified. It is open to atmosphere, so pressure at both the points will be atmospheric pressure itself. Also, there is no information of incompressibility given. It's given that you have to neglect all the energy losses. So we can consider the flow as incompressible, frictionless and steady. Therefore, applying Bernoulli's theorem, we have P1 by rho g plus V1 square by 2g plus H1 is equal to P2 by rho g plus V2 square by 2g plus H2. P1 and P2 are equal to each other. First terms on both sides will subtract out to 0. So we are left with V1 square by 2g. We can take V2 square by 2g to the left hand side. We have V1 square minus V2. The only unknown here is V2. So keeping V2 on one side, we have V2 square is equal to 2g into V1 square by 2g plus H1 minus H2. We know that the elevation difference is 200 millimeters. So let's substitute the values and find out the answer. This will be equal to 2 into 9.8 into 0.5 square divided by 2 into 9.8 plus 200 millimeters can be written as 0.2 meters. Because g is substituted in meter per second square and velocity is meter per second, we'll have to convert the elevation difference to meter. Finding this out in the digital calculator, we have V2 is equal to root over 4.174, which turns out to be 2.043 meter per second. Let's go back and mark the correct option. Options are very close. Be very careful while marking the option. So our answer is in option C, 2.043. So this is a problem from sand mold and it's a part of the gating system in metal casting. To learn more about this gating system, you can refer to the NPTEL video Design of Gating System 1. It's from the course lecture series on metal casting. The course is by Dr. D. Benny Karunakar. He is from Department of Mechanical and Industrial Engineering of IIT Roorkee. I hope the solution will help you clear your doubt. Thank you.